Hi everyone, hey, this is just a quick video to show you a process that you could follow to draw Lewis diagrams. And so in this one, I'm just going to cover the really basic kind of Lewis diagrams, the sort you would have drawn last year in year 12. And then I'll do another one that covers sort of slightly more difficult Lewis diagrams, the kind you might get at level 3. So I guess this is a kind of no-fail, Wilty's no-fail guide to drawing Lewis diagrams. And if you follow this, you'll get it right every time. And that is, after all, the name of the game. So I've written these letters up here, var, bok, dt. I don't know how you're going to remember that, or even if you want to remember it, but it is a process. So if you follow that process from left to right, you'll be fine drawing Lewis diagrams. So the first thing is the V. And V stands for valence electrons, right? So I'm going to choose an example, carbon tetrafluoride. It's a good one. And so carbon tetrafluoride has a certain number of valence electrons available to be distributed around the molecule. And the point of that distribution is to try and satisfy each atom by leaving it with a full energy level or a full valence shell. So the first thing is to count up the valence electrons. I have one carbon in that molecule and I have 4 fluorine atoms. First mistake some people might make is to count all the electrons in the atom. So carbon has 6 electrons, but only 4 of them are in the valence shell. It's just the 4 that we're interested in. Fluorine has 7. So I have 4 lots of 7, and 4 is 32, I hope, valence electrons to spread around this molecule. They are not owned by any atom. They are now available to be distributed anywhere in that molecule. So that's the V. Tick. The A stands for arrange. Arrange the atoms in space, and sometimes there's a bit of guesswork involved with that. But often when there's just a single atom and multiple of the other atom, it'll be the single one that sits in the middle. However, that's the A part. So we're arranging them in space. The B stands for a bond, a single bond between each atom. So there it is there. And you need a single bond, otherwise these things would fall apart. So they are bonded. Each bond corresponds to a bonded pair of electrons. And that is an important couple of words for you guys to remember for later on when you're explaining shapes and that sort of thing. So we've got bonded pairs sitting between each of the atoms, holding them together. And so I've now used 2, 4, 6, 8 of my electrons. And that's going to leave a certain number of electrons to spread around. So that will be 24 valence electrons to now spread around and satisfy every atom. So that's the A was a range, B was a bond. The next thing is to arrange all our remaining electrons around the outside, over for outside atoms first. So at the moment, I'm going to put 3 pairs of non-bonding electrons around each fluorine. So I've got 8 bonded there, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That's using all my available electrons. Okay, and so the last step is if you have more valence electrons available to you, you would put them around the central atom. And I'll try an example of that in a moment. So in this case, our central atom, carbon, actually has 8 electrons around it already. We've used all our electrons. And so looking at it, all of our atoms in this species are now surrounded by 8 electrons. Yeah, so actually that species is now complete. That's the Lewis diagram for carbon tetrafluoride. And that is without those circles, that is the Lewis diagram for carbon tetrafluoride. Moving on, so I'm going to erase that and we'll try a species that maybe has a slightly different arrangement. And so we'll go for ammonia. So let's take ammonia at NH3. First step is valence electrons. Clear that out. Let's take it through. Valence electrons first. Nitrogen has 5. I've got 3 hydrogen atoms, 1 electron each, 8 electrons to spread around. Yeehaw. I'm going to arrange them in space. I think there's 1 nitrogen and 3 hydrogens, so I'm going to just have a bit of a stab in the dark, do it like that. I'm going to stick 1 bond to hold these things together. That requires 2 electrons. So I've now used 6 of my electrons, used up. Great. That's my bond. And now I'm going to take, I've got 2 electrons left. I'm going to have a look at the outside atoms and I'll spread them around there first if I need to. However, hydrogen only requires 2 electrons to fill its 1s level, so those are in fact complete. So the outside atoms are now have full valence shells. My 2 electrons are moving to the central atom now. I'm going to stick my 2 electrons there. And if I look at that now, nitrogen has 8 electrons surrounding it. 2 non-bonded electrons and 6 bonded electrons, or 1 pair of non-bonded electrons and 3 pairs of bonded electrons. So that's nitrogen. Lastly, I'm going to do one last example which requires our last 2 letters in my VAR-BOK DT, and let's go for carbon disulfide. So again, valence electrons. Carbon has 4, sulfur has 6. I've got a couple of those, so I've got 16 valence electrons to spread around. I'm going to arrange them in space. I've only got 1 carbon, so I'll have a stab that it looks like that. Arrangement. Next thing, chuck a bond between them, hold them together. So I've now used 4 of those valence electrons and I'm left with 12. I'm going to stick the remaining, so I've bonded, I'm going to stick the remaining ones around the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's my total 16 electrons. Great. If I had some more, so I've used them all up now. So I can't add any more around the central atom. There aren't any more to spread around. I'm not allowed to chuck a couple more up here because I don't have them in this molecule. So I only have 16 electrons and they have all been used up to get us to that point. So the next thing is I'm going to look at each of the atoms and I'm going to say, well, sulfur has 8 electrons around it. That's happy. That sulfur has 8 electrons around it. It's happy. Carbon, however, can only currently see 4 electrons. Not happy. All right. So back to the drawing board, and I'm moving on to the last 2 letters of this VAR-BOK DT, and that is to create a double or a triple bond if you're in that position. And you do that by shifting pairs of electrons into the bonding position. So I'm going to do that on both sides, and that will create an electron configuration that looks like this. Sorry, not an electron configuration, a Lewis diagram that looks like that. And that is now a Lewis diagram, and I can tidy that up a little bit by putting those in a more trigonal planar arrangement. They're going to space themselves out. And that's looking good. So I hope that all makes sense. And as I say, I'll do a quick movie with some slightly more complicated examples for you to have a look at as well. All right, stay safe out there. See ya.